All right, we're back at it for Unit 7, Day 1. This is the beginning of systems. So when we are talking about a system of equations, we're talking about two equations in the same coordinate plane. So there's going to be two different lines when we graph these. So our goal today, when we graph both of these equations, is to find out where they're going to cross, because that's where the solution is. So what does it mean to be a solution? This is the ordered pair that makes both equations true. So if you were to plug in the ordered pair x and y, it will make the top equation true and the bottom equation true. When we were dealing with solutions earlier on this year, it was the number that we'd plug in that would make the single equation true. Now, since we're dealing with two equations with x and y, where we can graph them, we need to find both x and y numbers that would make the top and the bottom equation true when we have two. So if we take a look at this example, it says, is 1 common negative 2 a solution to the system? Well, once again, a system means that there's two equations in the same problem. So now we need to plug in 1 for x and negative 2 for y into the top and the bottom. So let's see if it makes the top equation true. So if I plug in negative 2 for y and I plug in 1 for x, that would give me negative 2 equals 4 minus 6. We're moving this way, we're moving up. Negative 2 equals negative 2. That works out for the top equation. But now the question is, does it work out for the bottom? So let's see if it works for both. Because if it doesn't work for both, then the answer is no, if it only works for one. So this would be negative 2 equals 3. And I don't think that's true, right? Negative 2 will never equal 3. So this answer is no, it's not true. Let me check to make sure that this is still recording. Oopsie. I do not see it recording. Let's see here. Oh, we are sharing. Okay, great. Great. Just making sure. All right. So for this next one, let's see if it makes the equation true or not. This is x and y. So now we have 1 for y and 2 for x, right? So that would be 1 minus 4 is equal to negative 3. And is that true? That would be negative 3 equals negative 3. So it works for the top one. But remember, it's got to work for both of them in order for it to be yes. So if we plug in the bottom, that'd be 1 plus 1 equals 2. So that'd be 2 equals 2. So it works for the bottom as well. So since it works for the top and bottom equation, this answer is yes. So you have a no and then a yes for those two problems. So one of them worked for both and one of them didn't work for both. The top one only worked for one of the two equations. So if we go on to the next page, this is where we're going to be dealing with some graphs. So these are the steps that we're going to be dealing with. Step 1 is to solve for y if necessary. For y if necessary. So you look at both equations, we're going to solve for y. Step 2 is to graph both equations. Step 3 is to find the intersection point. And then step 4 is to write your answer as an ordered pair. And that's always x comma y, right? So let's see what we we have here in the first one. So this top equation has a slope of -2/1 and a y-intercept of 0, 2. So if we were to graph this, we go to 0, 2, and then my slope tells me to go down 2/1 forever. So I'm going to dot that out, by the way. That way it'll make it easier to see where these intersect. So I'm going to go up 2 to the left one as well, continuously. So now that is my first line. I'll do my second line in purple so it's easier to see. So that slope is 1/1, and that y-intercept is 0, -1. So we go to 0, -1, we go up 1/1, and it looks like I can already see where they overlap onto each other, right? Hopefully you guys can see. Oh man, I didn't go up 1/1 there. I was wondering why that looked funky. Up 1/1, buddy. There we go. Now it's on an angle. All right, so it goes right here. So it looks like that intersection point, if you zoomed in, would be at 1, 0. Oops, put in the wrong spot. So where it says solution, this is 1, 0. And then that question is, does it make both equations true? Well, that's the place that it intersected, so it better. If you did plug it in, looks like you'd get 0 equals -2 times 1 plus 2. So you're going to get 0 equals -2 plus 2. So yeah, it makes the first one true. And then the bottom one would be 0 equals 1 minus 1, and that 0 equals 0. So yeah, it did. So if you plug it in, and if you did this correctly graphically, then you should always get a yes there, by the way. All right, so that's the first one. Number 2, we got to graph these. The top one has a slope of 0 because it goes left and right, and my y-intercept is 0, -3. So it says y equals -3. So I go to -3, and I have my dots that go all the way across here because I know it's a horizontal line when it says y equals. Same thing on this side. It just keeps going forever and ever and ever. So just a horizontal line. The next one, x equals, I know that slope is undefined for vertical lines. And it doesn't have a y-intercept. It actually has an x-intercept of 4, 0. So I go to 4, 0, and I draw my points that go vertical because this line has an undefined slope, which means that it goes straight up and down. So it looks to me like it's right here. If I zoomed in, that'd be at 4, -3. So I believe that is the solution. And does that make both the equations true? Well, if we plug it into the top, we'd get -3 equals -3. That works. If we plug in the bottom, we get 4 equals 4. So that's true. So yeah, that's a yes. So that's the first 2 examples of your notes. And then the last 2 examples. We got a solving for y one. All right, so if we solve for y for this far, or for this top one, we'd subtract 2x. Divide by -3. So we get y equals 2/3 x plus 1. So I go to +1, and I go up 2/3 forever. Up 2/3. Up 2/3. and I'll go down 2 to the left 3, which means the same thing as up and to the right. Down and to the left, just do the exact opposite. Oopsie, I didn't mean to make that mark. Down 2 to the left 3. I think those are all my points that are down 2 to the left 3 and up 2 and to the right 3. There's my first line. My second line, I'll go green. So that'd be 5x minus 3y equals negative 12. Subtract 5x. Divide by negative 3. And we get 5/3 x plus 4. So that tells me to go to 0, 4. And go up 5 over 3. 1, 2, 3, 4, 5 over 3. And then go down 5 over 3. 1, 2, 3, 4, 5 to the left. Oh, I think I found a place they overlap. So it looks like if you zoomed in, that's at negative 3, negative 1. And if you did this correct, yeah, it's always a yes, as long as you graph that correctly. And the last one, the top one's already solved for, so all I got to do is graph it. So that starts at 0, 1 as my y-intercept, and the slope tells me to go up 1 over 1 forever. Down 1 over 1 forever. So that looks good to me. The bottom one, I got to solve for y, so you got to subtract 2x. You get negative 4y equals negative 2x minus 4. And you divide by negative 4. You get y equals 1/2 x plus 1. So we go to 0, 1 and go up 1 over 2. 1 over 2 forever. And down 1 to the left 2 forever. So then in the end, it looks like they overlap at 0, 1. And if you plug it in, your answer is going to be yes. So that's day 1. That's finding the solution of these systems just by graphing them and finding out where they intersect. The next day will be slightly different. We're going to add something onto that. Have a great day. See you guys soon.